If you're there, welcome to the studio. How you doing?
Boom. What's going
How's it
on?
going? Nice to see you guys.
It's great. Would you mind with just starting with a little introduction on who you are, the company, and maybe a little bit of your background? Because I thought the previous company was really interesting too. So I want to hear about that.
Thanks. No, that's awesome. Yeah. So I'll tell you like a bit of the company. It's Atlas AI hardware engineer. The company's called Arena. We're based in New York. Yeah, background. I started out as an applied physicist. So I spent like a decade when I thought I was doing physics dealing with hardware problems. Again, this
Mhm.
was like a while back. Switch gears, did a brief stint through consulting. So wore a suit for a short flash of time over there. And then
Bring it back.
Yeah, it started right during that financial crisis too, which was a wild time to be starting a job.
Wow.
That's
Um,
insane.
but then sort of missed tech, moved out of San Francisco. The first company, to your point, was in 2014. It was called Kimono.
Hmm.
So the idea was to make it really easy. I mean, to write a web scraper, right? And it
Hmm.
was pretty popular. We grew to 150,000 users. We got bought by Palantir,
Hmm.
which is where I met my co-founder. We were there for a while, and then started Arena in 2019.
Very cool. Can you take me through the founding of Arena? How did you settle on this to build? It seems very on trend now, but you've been working on it for a couple of years. What inspired you? What was kind of like the early go to market, the first customer that you were talking to? What does customer development look like? All that stuff.
Yeah, totally. So just, we had a bit of an interesting path here. I would say it's like a little
Hmm.
bit non-traditional. We decided to bootstrap the company.
Oh, wow.
And so we said, well, if you think about like our view on enterprise problems, if you think about the B2B problem space, is there's almost like a Maslow's hierarchy, right? Which is
Hmm.
if you, let's say you've had a job for 2 to 4 years and you're like, you've encountered a certain group of problems, like you've encountered payroll, onboarding, communications. But then if you've been there for a while and you're deep in that industry, you're seeing another set of problems, right? And I
Hmm.
think one of the things Palantir did so well is they were able to go so deep into a customer for so long that they encountered problems that for which there was very little competition for. And like previously you had consulting companies kind of doing that. So there's I think a whole host of sort of untapped problems. And so our view is if we want to tackle problems that are really deep in an industry that are really valuable, we need to go really deep with a customer. So that's been the philosophy since the founding days. Instead of saying we're going to sell to other startups and sell
Hmm.
bottom up, the view is to start with a very difficult to enter customer, start top down. And the origin of the company was actually more, let's say, less vertically opinionated. We, had a depth in reinforcement learning and
Yep.
transformers. We're like, let's go and apply that for enterprise problems. So we were not as
Yeah.
sort of like, our thesis hadn't formed as sharply as it had today. And then we saw traction in a few different markets. And like post Chat GPT, we were like, look, I don't think for a small company playing in horizontal AI is really
Yeah.
a winner's game. But we found that like there was this beautiful intersection that went back to sort of my days as a physicist where like two different technical fields together with like, applied physics, electrical engineering,
Hmm.
and AI. Now you have an interesting customer set where you look at like a hardware test lab. It actually hasn't changed in a long time. The
Hmm.
incumbent competitor set are three companies from the 80s.
Hmm.
It's weirdly the underpinning layer of technology on which all of our software runs weirdly hasn't changed that much. Developing the hardware is like stagnant,
Yeah.
and it's kind of surprising when you think about it.
Yeah. Can you talk a little bit about like hardware engineering 101? Are we writing Verilog? Are we in CAD? Are there other systems? Like what does the work look like? And is this something where it's like it's managed on GitHub, so Devin's going to go off and write some code for you, and we're just doing fancy autocomplete? That's probably, I'm not trying to diss. It's incredibly valuable if that's what it is, but just concretize like what are we actually talking about here for the
Yeah.
folks who haven't done hardware engineering?
Totally, right? So let's break it down. Let's take a simple example.
Please.
Let's take something like a drone, right? Like
Yeah.
we've got like you've got like the mechanical shell where you've got like your mechanical engineering, CAD models, stress
Hmm.
strain modeling. Still a lot to do, but humans got pretty good at it. We've been building physical stuff for a while. Like,
Yeah.
we can screw things in, weld them together. Again, not trivializing that, ton of opportunity,
Yeah.
but that's kind of figured out. Now, inside, especially as you think about systems that are starting to go autonomous or partly autonomous, right?
Hmm.
You're like, I mean, we've had helicopters, now we have drones, right? So
Hmm.
what's the change? The brains of this are basically like a set of embedded systems, right? So embedded systems, effectively your computer, the green motherboard like you've got inside, except a whole bunch of them, right? You've got like one that's operating as a sensor and multiple
Hmm.
different types of sensors. So like an IMU for how you're oriented, like temperature sensors, optical
Hmm.
sensors. So all of your sort of sensors, just like the body has, and then a brain, and you might have multiple brains, which might be on board again in our drone example, flight computers, and
Hmm.
then you have actions that you take, like servos and actuators. And if you think about this, like inside that mechanical shell, you've got this almost electrical skeleton, sort of like your own nervous system sort of wired together, right?
Hmm.
And at that layer, to your point, there are two things that are happening. One is all of the electrical connections to make that work. And then for certain of those chips, you're running code on board. So to your point
Hmm.
about the Devon, so you might have an FPGA that's programmable, you're putting code onto it. And so that's sort of the sort of the we're currently at that inner layer. We're currently at that nervous system because there's this huge need. And if you look at like the kind of labor markets for a second, this is actually weirdly not surprising, but kind of has profound implications. The last 50 years, if you look at computer science course enrollments, they're up by 90%.
Hmm.
None of us are
Wow.
surprised by that.
Yeah.
But electrical engineering course enrollments are down by the same amount.
Yeah.
And so
Hmm.
you look at it, we've got this huge research, we've got tariffs, we've got all of that. We've got a huge resurgence in American manufacturing, right? And now you have all these intelligent hardware companies, robot companies, space companies, and like you have this burning platform problem where it's like, oh my God, people haven't been studying this stuff.
Yeah.
And like we're trying to now ship at the velocity of a software company in a hardware space where stuff can literally explode.
Yeah.
Without a workforce, right?
Yeah.
So you have
Yeah,
this
my favorite example here is you have Sonos, which has made like
started.
beautiful devices, but they haven't managed to like just get like even
I know.
like the collective experience of using a Sonos product is just completely brutal, right?
Yeah,
and
it's
then
rough.
and then you like look like this is a company with like hundreds, thousands of employees. They're public. And it's not even defense. Like it's not critical that my speaker work like when I want it to play music, right? It's annoying, but it's not the end of the world. And then it's like, hey, if that is hard in a controlled environment in a home,
Yeah.
and then we need to do much harder things in the sort of these defense
Yeah.
critical industries, like that should be a red alert.
Yeah.
yeah, it totally is a red alert, and that's where we've got customers kind of screaming for it. And at the root of it, like you have this idea that with software, I mean, you talked about Devon, right? Like, I mean, it's never been easier to write code, right?
Yeah.
It's like I mean, already weirdly, Python was an abstraction over like C plus. Like, it's not as hard as C plus plus. It's gotten easier and easier, and now like you're speaking in English, and like that's
Yep.
amazing, right? It's like the Star Trek computer.
Yeah.
And it's a beautiful environment because code doesn't need to obey physics. It just needs to render in your browser, right?
Yeah.
Now suddenly you're making contract with and nature, as we know, you guys go outside, you're like nature's unforgiving, man. It's not
Yeah,
like
yeah.
we haven't like fixed a bunch of we don't have space elevators. We don't have jetpacks. Like, no, we have like TikTok, which is great. But like what about all of that? And the problem is we're encountering this physics. And so each test cycle, to your point about the Sonos, is like, great, I have an idea. I'm going to prototype it. Like, let me run it in my terminal. It doesn't compile. Great, I probably made a stupid mistake. Everyone makes these. But the cost of making a mistake at that speed in hardware, like, worst case scenario, you get it wrong, something explodes. But then even on the development cycle, each time you're like, oh, damn, the board was wrong. I need to go and respin it. That's like you're adding 3 months to the cycle. And so these timelines and cost structures, I mean, we all know how much the F-35 program cost and overran. It's like that explains it. Like, I mean, there's a lot more that explains it, but that's like a piece of it and an important piece of it.
Yeah. Can you talk a little bit about where you see the most value to be delivered in the AI stack from, it sounds like you're not doing pre-training on a foundation model. Is fine tuning important? Is, building a system on top of existing LLMs important? Are you doing reasoning, or is it more about UI and integration into existing systems? There's so many different ways to create value in the stack right now. I'm sure it can be kind of overwhelming, but how are you thinking about it?
Totally. And it's a cool question because our own thinking on this has evolved quite a bit. I would say we started with a view that was much more we kind of need to own all the pieces on the modeling side and solve the hard modeling problem. And we sort of realized like what's happening is base cognitive functions are just becoming available as an API. So like vision is just going to be available. We shouldn't work on a vision problem. Like go fine tune like a YOLO or whatever VLM is your favorite. LLMs are maturing. But what we do find is if you think about like a person doing a work, imagine like our objective as AI is we're trying to get as good as like a medium class person, let's say, or like a junior person even, right? And we can unlock a lot of value with that. If you want to do that, now people do. If we think about you talked about reasoning, and there's a sort of like notion for reasoning in LLM land, but like if we just think about human reasoning, there's like a nuanced kind of like there are a couple of things that are special, right? There's some sort of like, especially in a formal environment like electrical engineering, there are certain rules of the world that we've learned over time that need to be true. It's like gravity is 9.8 meters per second square. You can't probabilistically learn that by watching stuff fall in air and being like, yeah, my ML no, no. I mean, there's just some law, like speed of light. Like you're
Yeah.
gonna encounter that shit. It doesn't matter if you're an ML model or like, it's just real, right? So
Yeah.
there's some of
Yeah.
these things which are hard constraints, and where AI has struggled is you tell an engineer something obviously wrong, they're never trusting you again. Like,
Yeah.
and they shouldn't, honestly. Like, you want to fly in a safe plane. You don't want that happening. So there's a piece here where it's like reasoning, but inside this sort of like structured, constrained environment, where there's a set of physics constraints that apply that you sort of need A, to win trust of the user, but B, to work, right?
Hmm.
The second piece is it's this kind of multimodality where, again, I'm not saying we need to build from the ground up those
Hmm.
models, but you need to make sure you're getting really clean input, right? And so that's input from, and it's weird, it's not like you're taking text input. Text is of course a part of it, and I
Hmm.
think the LLMs have gotten so good that it gives us an ability to like really ingest a ton of text documentation. For sure, that's a piece, but now you're also looking at the thing. You're looking at it visually, you're looking at thermally, is it getting hot? You're looking
Hmm.
at readings from an oscilloscope. So and each of those things has meaning to an engineer. And the idea is, can you now tease the right meaning from that? And so a lot of our work is basically on that data and fine tuning side. How do we turn all of that into a package that can be fed in to a set of models? And the other thing we found is, a person is doing multiple different pieces of work. A person might be saying, hey, I'm cross-referencing in some data sheets. What should this FPGA be expected to do? Can this pin handle 10 volts at 100 degrees Celsius? Or is this thing, am I going to short out the most expensive part? So that's almost like a kind of a text-based lookup. But then you're actually running a test. You're comparing waveforms. You're doing math. You're running simulations. And so what we found is we're using different systems to do the different different as agents to different pieces of the specialized workflow. So you sort of have this like meta agent that you're talking to, and then you have these others that are sort of, and the line blurs now between like what's an LM agent versus
Hmm.
what's it calling, we'll call tools. But those tools, if you'd talked to me in like November 2022 before ChatGPT, I would have been like, these are machine learning models and companies.
Yeah.
But they're just tools. Now it's like, oh, I need a thermal recognition stapled with like, the view from the waveform. That's an ML model. That doesn't need to be like a 600 billion parameter model, but it's a non-trivial thing to do. And so you can look at this entire
Sure.
constellation as being that's sort of the product, if you would.
Got it.
Um, one quote that comes to mind is we were promised flying cars, instead we got 140 characters. Um, I I have to imagine that what you're building and other tooling like it has a potential. The exciting potential to me is sort of getting us out of this period of stagnation. Right? There's a lot of companies that are building. There's companies building supersonic jets, right? And they
Hmm.
can use your tool. And then there's all these other things that we've yet to even imagine, or we imagined in science fiction, but now we should probably think about building. How optimistic are you around, AI helping to accelerate and help us sort of achieve these sort of like science fiction dreams that we've had forever, but have never quite been reality?
First of all, I love the quote. I think it definitely speaks to my heart. It's like if you look at and it's an interesting question because it can feel sometimes like reading the news like doom and gloom. AI is taking our jobs, and it's like I'll go back to an example that I lived as a physics grad student, right? I spent a lot of time, and I supposedly came in to do physics. I was like, oh, I'm going to do all this great quantum mechanics research, and I was basically like a mechanic and a plumber for like not like 99% of the time. I was like, this thing is leaking. I think there's a water leak. Oh, the screw got bent. Oh, like I was doing like less than 1% of physics, right? And I was like
Yeah.
that was the reality, and I think that's a reality for a lot of us. And so if you could take a lot of that away, like I think what it does is it changes, to your point, what human ambition should be. Like what could you achieve if let's say it takes 10 years on average to build a startup. In the past, like what we considered a SaaS company is now just going to be a feature for
Hmm.
in the future, right? And I think original Silicon Valley was about silicon, right? It was actually hardware based. And I think we're going to see a resurgence, hopefully, of that. And our hope is, like, what gets me personally excited is one of the magical moments at my last company, Kimono, was you took someone who couldn't code and you said, hey, wow, with this tool, you could, like, write a web scraper. And it was
Hmm.
like, we just got the most amazing, like, customer comments. And I was like, felt this joy of enabling people to do something. And, hardware can be intimidating. You're in, like, a hardware lab, even in college, you're like, oh man, this is really complicated. It's really, there's a high barrier. does it need to be that high? It's like we're seeing kids cheat on their essays with ChatGPT. That's a good thing. Will generate more stuff. What if we could let them cheat at Lab with this? Like, would we have more people going into hardware? Can we lower that barrier? Like, what if you wanted
Yeah.
to build a drone on the weekend? Like, you should be able to, right? You should have Jarvis. I mean, the goal is to be Jarvis and kind of enable everyone to be a little bit of a Tony Stark.
I love it.
I love it.
In your announcement post, you highlighted 5 categories that it seems like you're going after in the first initial rollout: semiconductors, aerospace, automotive, medical devices, and defense. Is that sorted by market size, like the burning need? Just, do you like the way that it sounded in that order? But I am interested to hear which of those has the most immediate need or is the largest market.
Yeah, it's a great question. So we started with semiconductors, right? So that's sort of why we put it first, because the most complex, especially when we think about a lot of what we do is electrical today,
Sure.
electrical engineering problems with semi. And if we take the philosophy of we want to be a little like Nike, start by selling it to the Olympic athletes, then get everyone to buy it, that was sort of the proving ground. And so we still have a few semiconductor companies, that we're scaling up to, but I think that's like we all know the household names. It's a small set that are really valuable, but they established the credibility. That actually helped us. We had a few great companies then come in inbound based on that. And a lot of that was automotive and aerospace. And it's interesting, especially you think about like EVs and like more autonomous driving and aerospace, you have a huge amount of that coming in. Medical devices, we've got an early customer in there, and it's like that's going really well. It's there's a whole like FDA angle to this that we sort of need to work through. We're newer to that, but it feels like the potential for impact is super high. And so that's sort of like a little bit like the landscape. I think we're seeing a ton of pull on the aerospace side. Like, especially as you look at that, industry is we're going to have more stuff that flies. And then you introduce space to the mix, and like aerospace and defense, like increasingly are kind of mixed. So you look at these things, I think that's becoming kind of a unit in some way. And so it feels like there's a ton happening there right now. But yeah, I mean, that's sort of just a little bit, there was not like a whole bunch of science behind that ordering.
Yeah, makes sense. I want to get your reaction to the tariffs. It seems like you're probably an American company selling to a lot of American companies. Regardless of what you think about the economics, it could potentially be a bull case for your company. How do you process the news, and what are you thinking about if it shifts your strategy at all over the next, using this Series B over the next couple of years?
Yeah, so it's we actually do have a couple of international customers too, and like I mean, obviously it's a huge impact, right? I think the first thing we did was just like call them because we're like, "Are you okay?" Like you especially look at these like the margins on something like a car have dramatically changed, right? It's like you're doing some of the work here, you're doing some of the work there, some of it in America. It's like there's a lot of American factories. What percentage of the cars actually getting made here is a totally different question. So you have a ton of like kind of a panic in the system, right? But you're right. Like for us, it's been like it's accelerated customer pull and deployments. They're like, oh no, like we can't go ahead and have like that gross margin impact and therefore have to do this with people. We need technology. And so it's actually a forcing function. Like if part of this means that US sort of quality and speed and sort of ability to manufacture needs to get up really quickly, and I think this provided the economic incentive for it, and it's just not there, honestly. This is just an accelerant. It's more fuel. There's more urgency than there's ever been on the customer side. So I would say like overall like a lot of like chaos there, but net I think like from our perspective good, because it means there's a huge pull, and like this problem we talked about, we talked about the 90% the changes in those people. Like we suddenly need to do a lot of this hard engineering in America, and it's this finally put like a dollar amount on how important that problem is.
How are you planning for kind of as AI technology gets better? It feels like we're firmly in the co-pilot era. There's a lot of talk about electrical engineering exam. I'm sure that these models have aced them at the highest level, and there's a prediction that AI will earn an IOI gold medal this year, and it's at like 50% on Polymarket, and yet I can't get AI agent to book my flight yet. So how are you planning for integrating that, taking advantage of what's state of the art and amazing and what AI does well, and then how are you building around the rough edges of the kind of innovation jagged edge?
Yeah, we think about this a lot because I feel like the question of defensibility probably is going to come up much sooner in a company's lifetime than it's ever done before. And
Oh,
so
yeah.
it's sort of like playing with fire, which is we want to be on the glide path where our product automatically gets better as the titans go to war and the foundation models improve, right? Like we
Yep.
just want to ride that wave. But if we're just that's what we're doing, we're like, let's get documents from the internet and help you do cross-reference. Okay, that's like not that is going to disappear super fast. And so, you know, to to your point, it's tied in with like your math Olympiad or physics Olympiad question, which is, yeah, you've got your friend who's the genius who's like really good at tests, right? And then you've got your friend who I bet is a different person who is really good at building stuff. And usually they're not the same person somehow. Like in
Yeah,
my
yeah.
experience, there's your tinkerer friend who didn't somehow get the A, right? That tends
Yeah,
to
yeah,
be
yeah.
the way. And so we're not trying to pass the math Olympiad. We're trying to be the guy who's tinkering in the garage, right? And so the tinkering in garage problem is very unsolved. Like you look at AI's capability there, it's like it's a disaster. But as the base cognition gets better,
But
you're getting better at
to
video,
be
right? Yeah.
to be clear, like when I think about the guy tinkering in the garage, my dad was a high school teacher, and he taught this class called Project Make, and it was some combination of like wood shop meets electrical engineering meets physics, and you're making rockets and all that stuff. So when I think about him solving problems, it's like the tinkerer in the garage, and that he would just try a lot of different things and experiment. And the beautiful thing about AI is like I have memories as a kid of him working on one little problem like for 5 hours, like on a Sunday, like trying to figure something out, whether it's around the home or in class. And like he's basically running like a series of experiments, right? And so the potential with AI is like run every experiment at once, like in a simulated environment, but like run like 1,000 experiments in like 10 minutes, right? And like when you start to think about what that can do for like accelerating progress, that's the most exciting thing for me, because it's a superhuman. It's like the tinker in the garage, but multiplied by a million.
No, totally. I mean, I want to get your dad signed up with the sort of we're working on like an academic edition. I want to
Oh,
give
cool.
him free access to that. See if he could even. We're looking for feedback, but I think that's
He's retired, but I'll put you guys
well,
in touch.
if he's
That's
still
amazing.
interested, if he's still
Yeah,
got a
yeah.
garage.
That'd be great.
Yeah.
Well, I mean, thanks so much for
No.
stopping
Here's
by.
the bar
Yeah.
for the team. 5 years from now, I want to be able to design our own podcast equipment.
Oh, yeah.
The
right.
most cutting edge. We need H100s in these things.
Yeah, and the microphone.
I don't know why yet, but it sounds cool. So.
Yeah.
Deal.
Congratulations. I do have one last question. How much do you attribute your incredible energy levels to your being a triathlete? Do you think it gives you an edge as an operator?
I would. I don't know. I would hope so. I do a lot less triathlon than I would like, but I feel like it does. Training the pain threshold is a useful thing. I think it's just a useful thing in life.
Yeah,
That's awesome.
love it.
Well, thanks so much for stopping
coming
by.
on. Congrats
One
on
last
the
Saigon hit
milestone.
for the Series B.
Thanks for having me, guys.
Congratulations.
Appreciate it.
We'll
That's
talk to you
fantastic.
soon.
See ya.